Today we are going to talk about number patterns. And when we talk about number patterns, we are talking about sequences. There are many types of sequences, but we are interested in linear sequences in this moment. So let's suppose that we have a linear sequence. Let's say 2, then we have 6, then we have 10, then we have 14, and we place these dots here to mean that this sequence is infinite. We say that this is a linear sequence because there is a common difference. If we subtract any of the terms from the one before, that is 6 minus 2, we're going to have 4, 10 minus 6, we're going to have 4, or 14 minus 10, we're going to have 4. This number is what we call the common difference. And when talking about sequences, no matter what type we have, there are two ways to describe these sequences, and that is when we talk about the sequence using something that we call the term-to-term rule, and something that we call the position-to-term rule. When talking about the term-to-term rule, we're just talking about describing the sequence in terms of how it starts and what we have to do, that is, what operation we have to do to get the other terms. For example, the term-to-term rule of this very simple sequence is something like start with 2 and add 4. That's very simple. That's what we call the term-to-term rule. Another examples. Let's say that I have 5, 10, 15, 20, etc. Term-to-term rule. Start with 5 and add 5. That's simple. Well, I want to talk a little bit about something that we call the position-to-term rule. And this position-to-term rule talks about a formula that we have to get in order to define our sequence. A formula in terms of the position of the terms. This formula is usually noted as Tn, and then we put, let's say for example that the position-to-term rule of this sequence that we have here is 4n minus 2, where n is the position of the terms in my sequence. The question here now is, how did I know that this was my sequence? And first of all, how do I know that this formula works? Let's test it to see if it works, and then I'll show you how to get those position-to-term rules. Many people get kind of very confusing processes, but I'm going to show you a very simple way to get it. But first, let's see if it works. If my formula works, that is, if it is correct, when I replace n by any of the positions here in my sequence, I'm going to get the corresponding term. For example, you see that the number 2 is in position first, that is in 1. N equals 1 for this. N equals 3 here. So if I replace n by 1, I'm going to have to get the first term. Let's see if it works. If n equals 1, that is T1, by replacing that in my formula, what I have is 4 times 1 and then minus 2. That is 4 minus 2, and that's going to give me 2. So it's correct. But let's see if it works for the third term, when n equals 3. When n equals 3, what I have is 4 times 3 and then minus 2. That is 12 minus 2, and that is going to give me 10. So as you see, it works. And the good thing is that if we are ever asked to find, let's say, term in position 100, we don't have to find the 99 terms before this one. We can just go ahead with the formula and find it on the spot. I'll show you. 4 times 100, and then minus 2. That would give me 400 minus 2, and that's going to give me 398. You don't have to get all the terms before the 100th to know that term in position 100 is 398. In another video, I'm going to show you how to get these very easy position to term rules. See you soon. Bye.